So let's go through trying to graph a couple of these functions right here using as our guide the secant, the cosine or sine graphs as appropriate to give these graphs. So let me show you how this works. All right, I want to graph y equals 2 secant of 3x. So as a guide, I'm going to graph the function y equals 2 cosine of 3x, and just note where I get zeros, where I get maximums, minimums, because that's going to give me locations of my asymptotes and so on. So we're going to graph this for one period. This is my guide. Let's see. So I know my amplitude for cosine is going to be 2. And that my period will be 2 pi divided by b, in this case 2 pi over 3. My key points within one cycle of my cosine function would be 1/4 times the period apart. If you multiply that out, that's 2 pi over 12, but that reduces to pi over 6. So each of my key points are pi over 6 apart. Now keep that in mind, because when I graph my cosine function, I would have to mark my axes using those increments. So starting at 0, pi over 6 would be my first key point. 2 pi over 6 would be my next key point. Well, that's pi over 3. 3 pi over 6 would be my next key point, but that reduces to pi over 2. And then 2 pi over 3 would be my last key point within this one cycle. And so for my cosine graph, here's what happens. My cosine, let's make a nice thin line, cosine starts at 1, is going to start at 2, is going to go down to 0 at pi over 6, goes to -2 at pi over 3, will go to 0 at pi over 2, and we'll go back to 2 here at 2 pi over 3. So here's 2, here's -2, just for continuity's sake. And so if I'm graphing this cosine function, cosine would be following this curve, and I'm just going to dash it in really, really lightly. So I'm going to sketch my vertical asymptotes at any place where the cosine graph would normally cross its horizontal axis. That is at pi over 6. So we're going to graph pi over 6 at pi over 2. Where the cosine graph is equal to +1, the secant graph is equal to +2. The secant graph will also be equal to +2, and it will take a reciprocal behavior to the cosine function, so it comes up along its vertical asymptote this way. At pi over 3, we'll have -2. We're going to come along our vertical asymptote at pi over 6, and then go back down towards our vertical asymptote at pi over 2. At 2 pi over 3, 2 secant of 3x would be 2. The graph will come down along the vertical asymptote, pass through the point 2 pi over 3, 2, and then start heading back up, and we'd have our next loop here. Some things that you would want to know for this function, well, of course, the period is the same as this cosine function. So the period is 2 pi over 3 for this function. You should be able to find 3 vertical asymptotes of any one of these functions if you're asked to do it. So our vertical asymptotes in this case, we found 2 of them, right? We found a vertical asymptote at x equals pi over 6. We found a vertical asymptote at x equals pi over 2. If we want to find another vertical asymptote, well, we might ask ourselves, well, how far apart are these ones? Because the next vertical asymptote will be the same increment apart. Well, pi over 2 minus pi over 6 is the same thing as saying 3 pi over 6 minus pi over 6. Well, that reduces to 2 pi over 6, which is pi over 3, right? So they're pi over 3 apart. So what we'd have to do to get our next key point, starting at pi over 2, is add pi over 3 again. Well, in this case, pi over 2 plus pi over 3 is to say 2 pi over 6 added to 3 pi over 6. We would have one more vertical asymptote at 5 pi over 6 on our graph. So that would be one more that we could get very easily. All right, so let's talk about a cosecant function, similar in nature. Cosecant function. Cosecant function, we use sine as the guide right here. So let's use a sine function. A related sine function would be y equals negative 1/3 times the sine of pi over 2 times x. So our amplitude in this particular function is equal to 1/3. It's the absolute value of negative 1/3. The negative means there's going to be a reflection. Our period, 2 pi over b. We take 2 pi divided by pi over 2. Multiplying 2 pi times 2 over pi gives us a period of 4. And of course, 1/4 of the period is equal to 1. So key points are 1 point apart. So what I'm going to do on my graph is I'm going to mark my x-axis so that each of the key points are 1 apart. My y value only goes up as high as negative 1/3 or positive 1/3, so we're going to go to 1/3 right here. I'll make this 1. I'll make this negative 1. I did that because there's 3 places in between. So here's negative 1/3. And here's positive 1/3. All right, so what's going to happen right here? At our key points for this sine function, we know it would start at 0, 0. We'd have at 1, negative 1/3, since we're going downward this time. At 2, we would be back to 0. At 3, we'd be at positive 1/3. At 4, we'd be back down to 0. So one graph of that sine function, I'm dashing in lightly here, on the interval from 0 to 4. Anywhere where the sine function has a 0, we have a vertical asymptote. So we have a vertical asymptote at 2. We have a vertical asymptote at 4. But don't forget, we also have a vertical asymptote at 0. So if I'm graphing my cosecant function, I'm going to make my branches here come along our vertical asymptote, go up to the points where the sine is at its maximum or minimum, come along the vertical asymptote, go back along its vertical asymptote. Just as before, the period is still the same as it was before. In this case, the period is 4. We should be able to name 3 vertical asymptotes. In this case, it's a little bit easier because we know where those asymptotes are. X equals 0 is one of them. X equals 2 is another. X equals 4 is another. Right? These are 3 vertical asymptotes. But we can continue on very easily because it looks like they're just going by even numbers. So this would be a rendition of our graph of the cosecant function. All right, tangent and cotangent, more to come.